Welcome to the Marco Polo Sphero project. Let's dive right into the overview. The basic idea of the project is Sphero will be playing Marco Polo with the bowling pins. The Sphero will hold a trailer that will hold two microphones that will act as the ears of the Sphero. We'll gather the time difference between these microphones, compute the readings, triangulate the pin's direction, and then send the direction to the Sphero. The microphones will be connected to an Arduino that will gather the time delta, pass it on to the Raspberry Pi, which will then transfer it over to the laptop and then over to the Sphero. Although I wasn't able to reach this, we ended up having to bypass the Raspberry Pi and plug it in manually for the time being. Although adding the Raspberry Pi would be very interesting. Let's look at some demos. Here we see the time delta in action. With the pin to the left of the Sphero trailer, we are getting values that are below 200, signifying that the pin is either to the left or to the right. With values above 200, it shows that the pin is forward, and as you can see, there's a lot of instances where it thinks the pin is in front of it, or rather to the side. And here we see the actual speed of the testing and the sound of the pin. The following test will be sped up. And each of them show the Sphero getting pretty close to hitting the pin. I found that knocking the pin over on a hard surface is much more difficult than on carpet, which is what I originally tested. It gets so close. Now let's take a look at the modules. First, we'll take a look at the pin design. The pins are 3D printed, and they are composed of two pieces with the speaker mounted in the middle, and the wires are threaded through the bottom. The basic idea of the pin software is that each pin would randomly emit a tone, and the Sphero would have to decipher between them. Although this wasn't able to be implemented, I was only able to implement one pin, and the idea would have been to implement 3. Now let's move on to the Sphero trailer. The trailer holds the Raspberry Pi, the Arduino Nano, and the 2 microphones, and it ensures that the microphones are spaced 10 centimeters apart so that we know the distance between the sounds reaching each microphone. Here we can see the building of the trailer as the electronics are put on. It's surprisingly compact, although it is missing a battery. So now let's move on to the Sphero code. Here we are looking at the ROS nodes. This is an RQT graph composed by ROS, and we see that we have 4 nodes. The serial node communicates with the Arduino Nano, and the Sphero node communicates with the Sphero, and the 2 nodes in between are what figure out the direction and pass it on to the Sphero while gathering the time delay from the Arduino Nano. So the serial node passes the time delta to the update node. The update node then determines if it's forward or left or right, and then the analysis node converts that into a direction and a speed, which is then passed on to the Sphero. And here, just looking at how many terminals I had to have open to run every node because I didn't set up any launch files. Now let's take a look at some of the bloopers. Here we see my first use of PySphero. As you can see, it was more effective than my grid search during bowling. And here we see me trying to run the Sphero with the trailer. And here we see me using the trailer on my desk. Glass surface worked a lot better, maybe too well, than the carpet. And here we see it trying to move with the battery pack that I was hoping to install, but that did not happen. Now let's jump into acknowledgements. I want to thank all the doctors who helped me during the lab, including Michael, Anthony, Josh, Joseph, and Petrucia. You guys all gave me some great ideas, and I wasn't able to implement all of them, but they were all very useful. Here's a time lapse of me working on the robot. Feel free to ask me any questions. Thanks for watching. I hope you enjoyed.